Hi, welcome to Math Motive. In today's class, let's discuss the topic called permutations and combinations. The first definition we have to know is the counting principle. The fundamental counting principle is used to count the number of outcomes when an event occurs or a sequence of events occur. That is the purpose of the fundamental counting principle. An event is an experiment, and the example for an event is tossing a coin or rolling a dice. Example for a sequence of events is tossing a number of coins or rolling a number of dice. Let's count the number of outcomes. So consider example 1, tossing 2 coins at a time. For tossing 2 coins at a time, the number of total outcomes are calculated as 2 square, that is 4. The set can be written as this. Now for tossing 3 coins at a time, the total number of outcomes can be calculated as 2 cube. So that is 8. The set can be written as this. Now let's look at the general formula. The general formula for calculating the number of outcomes while tossing a coin is 2 power n, where 2 is the number of outcomes when a single coin is tossed, and n denotes the number of times a single coin is tossed, or n coins tossed at once. Now let's consider the case of a dice. That is example 2. While rolling 2 dice at once, the total number of outcomes are this whole set. This whole set, okay? The total number of outcomes can be calculated as 6 power 2, that is equal to 36. Now let's look at the generalized formula. The generalized formula is 6 power n, where 6 is the number of outcomes when a dice is rolled once, and n denotes a single dice rolled n times, or number of dices rolled at once. Permutations and combinations are counting principles. They are techniques or formulae which are used to count the total number of possible outcomes of an event or a sequence of events. Permutations are the ways to count an arrangement. Example, the rank of a word in a dictionary. The formula is NPR is equal to n factorial by n minus r factorial. Let's solve a problem on permutations. Arrange the letters of education in such a way that all the vowels come together. How many arrangements can you make? In the word education, there are totally 5 vowels. They are E, U, A, I, O. The vowels together should be treated as one unit. The number of arrangements which can be made internally among the vowels can be calculated using the formula N, P, R, where N is the total number of letters available, that is 5, and R is the total number of letters to be arranged. So that is 5P5. That is equal to 5 factorial. They are calculated as 120 different ways. Now treating the vowel unit as 1, D as 2, 3, C as 3, T as 4, and N as 5. The total number of arrangements which can be made are, again, can be calculated as NPR. That is equal to 5P5 again. That is equal to 120 ways. Now the total number of different arrangements are the number of vowels together treated as one unit and DCTN plus the vowel unit, and they are calculated as 120 into 120. The total value is 14,400 different ways. We are multiplying because it is and not or. According to the counting principle, if it is and, you have to multiply. So, the total number of ways are 14,400 different ways. Now, let's look at the visual explanation of the same problem in the next slide. Thank you. Now, let's look at the number of different ways in which the arrangements can be made visually. Draw 4 blanks. 1, 2, 3, 4, 5 blanks. In the first blank, the options are D, C, N, T and the vowel set. That is 5. In the second blank, it is C, N, T and the vowel set, that is 4. In the third blank, it is 3. In the fourth blank, it is 2. and in the fifth blank it is just the vowel set. For the vowel set, the internal arrangements can be made as treating the vowel set as one unit. The total number of arrangements along with the other letters are 5 factorial. D, C, T, N and the vowel set, that is 5 in number. That is, so the number of different ways are 5 factorial. Now internally the vowel set can be arranged in 5 factorial different ways. Let's explain this visually. For the letter E, the options are U, A, I and O. U, A, I and O. So the total number of options are 5 here. For the second place, the total number of options will be 4, including U, A, I, O are counted as 4. For the third place, there will be 3 options including A. So it's A, I and O. For the second place, the options will be 2, including I. So it's I and O. The last option, the last space, in the last space, the only option is O. So it's 5 factorial. That is equal to 5 factorial. Now, the vowels can be arranged in 5 factorial different ways, and D, C, T, N and the vowel set can be arranged in 5 factorial different ways. So according to the counting principle, if it's AND, you have to multiply. So multiplying 5 factorial into 5 factorial, we get the final answer as 14,400 and different ways. More videos coming from Math Motive. Please like, share and subscribe. Thank you.